Once again, hello everyone. I'm excited to be here in France. Last time I was speaking in France, I believe was in 2014 in DroidCon Paris. So thank you for coming today. Today we are going to talk about building mobile SDKs. The things that our company is doing that for quite some time, like for 5 or 6 years, and building SDKs is hard. It's very easy to get things wrong, and when you get things wrong, a lot of people suffer. But before we are going to get to the presentation, let's play a quick show of hands. Raise the hands whoever integrated a third-party library or the SDK. Like Facebook, Google Play Services. I believe everybody integrated Google Play Services. Okay, pretty much everyone. Who integrated Google Play Services, any library, and it didn't work quite as you expected? Raise your hands. Maybe the size was not okay, maybe the integration process was complex, and it didn't even finish the integration. Today we are going to talk about how to avoid that. But before that, let's figure out who the hell am I and why I'm on the stage. My name is Vitaliy Zasadnyy. I'm leading mobile department in the Dutch startup called GetSocial. Besides doing some techie stuff, I run Google developer group back in Ukraine. And actually, 1 week ago, we had exactly the same DevFest in my home city. And I like to share my experience. I travel around the world because I truly believe that only when us developers are going to share their experience, the whole community will grow, and we are going to push the progress forward. Just to give a bit of background about our company, we are building a social layer for mobile applications and games. You can think about it as a small Facebook you can put into your app. And with a couple of lines of code, you will get newsfeed, invitation platform, referrals, stuff like that. Our SDK is available for all major platforms like Android, web, iOS. We even started Web SDK recently. And today, I'll mostly focus on Android. We are on a Google Developer Conference. So let's start. SDK Lifecycle. When I just started building a library, when I actually created my first library, I was pretty sure that I developed it, and that's it. I published the library to the GitHub, and then something happened. I suddenly started getting requests. I started getting questions in GitHub issues. I started getting feature requests. At that moment, I understood that development of the library is actually on the very, very beginning of the whole life cycle. There is much things behind that. And today, the way we are going to structure our meeting today is we'll talk about what you need to focus during development of the library, what to focus during the integration time when your clients, when your developers who you are building library for, how they should integrate it. And then we are getting to the support update loop. Let's start from the development. So imagine, you got a task. You have to build a library. For instance, an invitation. A simple library to help people to invite each other. You have to shape your API somehow. And the easiest way to do that is to build use cases. You always have to start from describing, from understanding on how your users are going to use your library. And when we are developers, and that's actually what we did for first 3 versions of our library, we just started writing codes. Without any use cases, we knew that, okay, we have to have share functionality. We started building networking. We started writing a lot of some layered codes and nice architectures. We totally forgot about our users, the people who are actually going to use our library. And we did quite a lot of stuff. We wrote a lot of code, but later we had to rewrite it. Because when we actually got to shaping our API, when developers started using it, they provided feedback, and we had to restructure it. When we were shipping our latest version, our latest major version of the SDK, we took the different approach. We created the whole set of use cases. For instance, developer want to share invitation. Developer want to share invitation with custom text. Developer want to share invitation with custom text and image. Next stage was to build an examples. We were shaping we were basically writing the documentations that we'll later publish to our developers. Like, in order to send an invitation, write this part of code. In order to send invitation with text, write this part of code. And while building those examples, you will find out like, that maybe what you initially created is not very comfortable to use. But at this point, it's super easy to change because you don't have any communication, anything behind it, just public API mocked without anything behind. And then you may write some code, but actually not the actual code, but integration tests. What we did for last version of our library, we tried test-driven development. It was painful as hell. Our developers were swearing as hell, but we did it. And you know what? Integration test was the best thing we introduced on the latest version of our library. The reason for that, you get all the documentation, all the specification on how your library should work on different conditions for free. And over the time, when your API progresses, when you change something underneath, the integration tests will be your safety pillow to make sure that you are not going to break anything for your clients with the new releases. With this, I want to point that we all know that the cost of fixing the bug is like more and more expensive on the later stages of the development. With the API, it's exactly the same. The cost of fixing the poorly designed API on the design phase on our use cases stage or example stage is 10 times cheaper rather than changing all the shipped API. And if you are not sure of should I include this method or not, just drop it. Adding new methods or new functionality to your library is much, much easier rather than removing it from it. And this will lead you to writing less code. You'll write less code, you'll introduce less bugs. Less code you write, less space to introduce new bugs. That's true for us as developers of the library, and that's true for the end users of your library. And you have to design your API in a way so developers write less code. Because if your API will be very verbose, your clients are going to write a lot of boilerplate code. They're going to copy-paste it because nobody likes to write same over and over again. And they're going to end up with bugs, with wrong implementation of your library in their code. And we had this. We had this in like all our versions of SDK till the last time. For instance, to make our library just run, you have to add app ID to the manifest. You have to find the activity that is going to be opened from the deep link. You have to go to dashboard, copy some IDs. Don't look at the code, just look at the amount. You have to add receiver for analytics. You have to add content provider, more and more. And to top up with everything, you have to initialize manually. A lot of code. Especially funny was this one. It wasn't like this receiver for installed referrals on Android to understand when application was installed from our invitation. For SDK functionality, it was like, not really important. SDK was working, deep linking was working, everything was fine, except one small part. We were building our we were billing our clients based on analytics they reported. So basically, if developer, just by accident, forgot to include this into their manifest, we didn't know how much we should charge our developer. It was a huge business issue. So how to solve that? We know that we want to let our developers write less code. And in case of Android, there are quite of options. The first thing we did is we ship our library in AAR format. And in AAR, you can provide parts of manifest file that are going to be merged into the main application. And this application install refer receiver was the first thing we added to our manifest that had to be merged. And that saved us a bit. But still, we had to write all this deep linking manually, all the intent providers. We couldn't just merge them because they had some parts of the information that had to be fetched from the dashboards, from the developer console on our website. So we came to a next solution. We wrote a simple Gradle plugin. We were inspired by Google Play services, and for a long time we were postponing this project of writing Gradle plugin for our library once and once again because it looks so complex. But actually it is not. I'll stop by for one more option. Gradle plugin is not the only option you have. You can go even further. If you look into how Firebase is integrated or how Fabric used to be integrated into Android Studio, they provide a fully featured Android Studio plugins where you just log into your developer account and you can integrate with click of one button. And there is like more and more options. You just need to be creative and always strive to let your end users write less and less code, because more code you write, the more bugs you're going to introduce. About Gradle plugin. You remember all this like bunch of code. At the very current moment, to integrate our library, you have to apply plugin and provide app ID. The rest will be just happening behind the scenes by pure magic. Like, there is not much magic, but having the app ID allows us to go to our dashboard, fetch all the configuration, parse the manifest file, generate everything on the fly during the build, and developer doesn't have to do anything. But we decided to go even further. Remember I told you that developer had to manually initialize our library. And the thing with initialization is that you have to find the only entry point for your application. First thing that comes to Android developer's mind is you have to override application class. Just specify it, override application class, specify the proper class in the manifest, and you're good to go. But then we are getting back to the problem that we force developer to write more code. And there is actually an alternative solution. Did you know that content providers are the first thing booted up on the Android application in general? Content providers are loaded into the system before any part of the Android application ever. And you can simply implement content provider. Inside you will do anything related to content serving, but this will be the entry point that is invoked before any receiver, before any application, before anything in your application where you can initialize your code. Actually, Firebase is working like that. Less code is better. It's better for you as a developer while developing library, and it's better for your end user. And when you are trying to make your API as compact as possible, you can get into the trap. You will fall into patterns. You will see that those 2 or 3 methods are usually used together, so why won't we merge them together? And that's where we introduced a problem 2 years ago. Before we are going to get there, I'll give you a very common example that was introduced by Java developers back in 90s. Do you know what does the thread interrupted is doing in Java API? According to documentation, it says it returns current state of the thread, if it's interrupted or not, which kind of makes sense, and clears it. What? Why the hell we return the current status of the thread and we should clear it? The designers of Java API were sorry about this method, and they deprecated it in later versions, but that's something that you have to be aware of. When you are designing a method, make sure that the signature is clear, and even if you have this temptation to merge functionality together, make sure it's clear for your end developer and you don't fall into this trap. The story that we have a user management framework. Basically, you can merge your accounts from different social networks. And we had a client who had a game about zombies or something like that. And what we did, when you log in with your Facebook or Google Plus account, we automatically fetched all your information and updated your profile with your real name. The developer came to us screaming why the hell all the new users after update has real names in my app? They had names like Zombie1, Zombie2, Scary Zombie, and now they are have real names. Oh, be aware of that, and don't fall into the traps into the merging too many APIs together. As Chris Sells from Google, that's the guy behind .NET Framework, one of the designers, said, you have to make your API as boring as possible. Don't try to surprise developers with how your methods behave. Instead, try to surprise him with how stable is your application. And now we come to another important point. How you are going to feel when you integrated a third-party library, and in one of the mornings, you open Google Play Developer Console, you log into your crash report, and you see that the library that you shipped, the new version of application, is crashing because of the library you integrated 2 weeks ago. And maybe you lost 20 users, maybe you lost 500,000, but I doubt you want to be a developer of the library who crashes the application. We tend to get very mad when we see that. One of the statements that we did for us at GetSocial is that we promise that we'll never ever crash the host application. And the way how do we achieve that? First, we use RX chains and RX error handling. We'll get to that later. Second is developer mode. And in our case, developer mode is something we call execution policies. Basically, we have two options. In a developer mode, we use a strict execution policies. That means that if anything is, like any exception is thrown inside the SDK, we just crash everything. Like when our QAs are testing our application, when we are developing, we use this strict execution mode and everything just crashes. But when we go to production, we use something called safe execution mode. You can think of it as a huge try-catch and in production, we don't crash. Instead, we log everything like nicely to the logcat and send to our internal analytics to understand what is going wrong with the application. And we use a lot of static code analysis tool. Pretty much every imaginable static code analysis tool we tried, most part of them we use. Like nullable, annotations, PMD, find bugs, lint, all this we use. And we don't just use them, we use them on the most strict mode possible. When you are developing an application or library, or when you are developing for application for your end user, you can afford yourself to lower the boundary. Because you know that, okay, we may allow like certain lint rules to avoid, but when you are developing library, you cannot guarantee that end developer, the end user of the application, don't have more stricter rules rather than you have internally. Actually, situations that we had yesterday. We are preparing to the release of this one huge Japanese customer, and they asked for us a tiny feature before their major release. We quickly developed them, shipped, and this morning I got an email, you know what? Your new version of library doesn't build in our system. We started looking into what was the reason behind, and actually they were just using even stricter permissions, like even stricter setup of the static code analysis, not on Android but on Unity, rather than we do. So be aware of that. Quick note about the RX chains, we're just huge fans of them. Before functional approach, we used to use like tons and tons of callbacks, and we had this huge callback hell. And when you have like callbacks in callbacks in callbacks, you have to give like pop-ups exceptions to the top, and it's very easy to miss something and just crash. RX, or pretty much any functional approach for development, gives you a nice way to streamline all errors to one place, to one collector where you can transform, log them, or do whatever you want to like recover or just gracefully shut down. Next thing, it's about hiding internals. In SDK version 5, now we are on 6, we used to have just a lot of public classes and a lot of internal classes, and everything was just in the same packages. It wasn't too bad, but it causes two problems. First, when you try to import something, you can see like a whole bunch of classes that ideally you should not touch as a developer, as an end user, but you don't know about that unless you are going to check the documentation. And another problem was, like we had a huge list of classes in our Java doc generation task that need to be generated. And when we introduced new class, we had to add it manually to reference doc generation, which was a kind of problem because we usually forgot to do that. What we started doing, oops, I scrolled too far. What we started doing from the version 6 of our library, we introduced internal package. So if you can see, like everything that developers should not touch just goes into internal. That's the approach that Eric's Java used to use and a couple of more libraries. So use internal package. It's going to explicitly specify what should not be touched by external developers, and it's going to simplify you the reference documentation generation because you can set a simple rule. Everything that is internal is in internal something package, just don't touch it. Generate documentation only for classes that are outside of the internal package. And one of the settings that we force our developers to enable is to create all the code, generate all methods, generate all fields, and generate all classes private by default. This is kind of annoying, because then you have to manually set the access level that is needed. But this way, you will always pay attention and ask yourself a question: is this class need to be exposed? Or maybe I should move it to a different package and set the internal access level. Don't expose too much to your developer, because later it's going to end up creating compatibility issues. Those were just a couple of highlights that were like maybe the most painful for our company. But if you are working on the library for a huge amount of users, or you are just working on a small module for your teammates, I highly recommend to go through those two books. Like, first one is Practical API Design. It was written by a guy who created NetBeans API. And the second one is from team who designed .NET framework. If a Practical API Design is like really practical advices, like do this, don't do this, framework design guidelines is more a discussion on why .NET framework looks like this and not like this. They describe a lot, they discuss a lot, like why certain decisions were made, with a lot of arguments and pros and cons for each decision. Now let's talk about integration. So you developed your library. You push it to GitHub, you push it to Maven Central, you push it to the live. Now is the time to integrate. Now it's time to integrate for our clients. And how do you think? What is the important factors for our clients to integrate? Any ideas from the audience? What do developers care about when they make a decision if they should integrate your library or not? Once again? Empty issue tracker with no issues inside. Other ideas? Good documentation. More ideas? Active community. So you kind of get the idea of what should be behind the good library. But what we found, like documentation is a must-have, community is a must-have, but when we integrate with our clients, they actually care about the size. And from our experience over the last 4 years, the size was the reason why developers decided to integrate with one client over another, with us or not us. And by size, I mean not only the library size, but also a missed count on Android. If for native applications is not a problem anymore, because we have multi-decks and we kind of have in a native environment how to handle that. When we are talking about Unity development, the most popular game engine on the mobile at the moment, up to the latest version of Unity, which was released like half a year ago, there was no a single way to enable multi-decks. So imagine, you build a huge game, and you don't have a way to cross 65K limit. It was a huge problem for us because our library incorporates a lot of parts and a lot of networking, a lot of features. Our library was quite big. We were always fighting with missed count and library size on Android. I can make a separate presentation about that. If you're interested, let's talk after this presentation. So that's something that you have to care about. And one important thing is to measure it all the time. What we did on our continuous integration server, we have a plot that always tracks the library size and the missed count. And if we see the spikes, we always roll back and see, okay, maybe this feature should be implemented in a different way. We cannot, this feature is not worth this 200 extra misses or something like that. So set up continuous integration and measure all your library size and missed count all the time. And care about ProGuard rules. That's something that it pops up over and over again. And ProGuard is things that I personally hate to configure. Make your developers' life easier and provide them pre-made ProGuard rules. Next, let's talk about compatibility. Remember I mentioned about internal package and why it is important. So developers don't use something that was not intended for public use. That's one side of the compatibility. But there is another side. When you are developing for Android, we have a lot of versions of Android, and we don't, as an Android developer, we don't like to play with older versions of Android. We don't like to support all this backward compatibility, because always we have all those new shiny APIs that Cheat and Roman were talking on the previous stage. And we always try to use them as much as possible. And it's very easy to bump up the minimum required version, but you should really check very carefully on what is the minimum supported version. Luckily, Android and iOS and Unity always provide the market share for all the versions of Android, but you have to take into account also for which market are you working. In our case, we were lucky or not very lucky that our SDK is not very popular in the Middle East and India and that part of the world. And we have this luxury of bumping up our SDK level to 14, but there are actually companies who have to take care of the older versions of Android 2.3, and you have to find the information, the sources of this information that are specific to the market you are targeting. That was about lower boundary, and about upper boundary. When you build your Android libraries, always try to use the latest tools, the latest possible, so you know how your library is going to behave on new versions. The kind of sad story or problematic story we had when multi-window mode was introduced. All our windows in multi-window were just going nuts, back, forth, stretched, and were not behaving well. Luckily for us, now we have release candidates for Android, and we can test all this in advance. Now let's talk about support. Actually, US audience, you already know that support is important, the community is important. And when you release a library, you should provide an easy communication channel for a feedback, for reporting issues. It can be a GitHub issue tracker, it can be intercom, it can be just a support email, but provide something for your developers. If I, as a developer, will start integrating a library and I'll get into some problem and I won't be able to solve it in 15 minutes, in half an hour, there is high chance that I'm going to find just another solution, another library. Because spending a lot of time into fixing something that can take indefinite amount of time or undefined amount of time is not what we can afford with the current state of the market. And when you will provide this channel, you will face a situation when you will get the same questions over and over again. You always will be asked how to initialize, or what providers are supported, or any other kind of these repetitive questions over and over again. The easiest way to solve it is to provide a good documentation. But we are developers, right? Who here likes writing documentation? One hand. We don't like to write documentation. And in software-driven company, it's always an issue. When I just joined the company 3 years ago, all our documentation was a single markdown file on the GitHub. I like the saying that bad documentation is better than not having documentation at all, and that's fairly true. But if you want to provide the best user experience, the best integration experience to your clients, you have to make sure that you have a comprehensive documentation. And what do I mean by comprehensive documentation? You have to have step-by-step guides how to integrate your library. You have to have documents that describe how your product can be used, all possible use cases. In case of our imaginary invitation platform, invitation library, you can say that, okay, you can use this just for basic invitation or referring friends. You can invite people to multiplayer games. You can invite people or share some internal some screenshots from the game or something like that. Those use cases are going to simplify your life in the support, because people will ask, if I can use this library to share content, if I can use this library to invite people to the game. And of course, you have to have all your API references, basically your Java docs generated. If you are going to look through our most popular documentations, we have Android, Twilio, or our one, you will see exactly the same structure everywhere. And there is one more thing about providing code snippets in the documentation. Do you know what's wrong with this code snippet? Any ideas? What will happen if you'll just copy-paste this code snippet from the documentation to your IDE? You're going to see compilation error. One thing that we learned over the course of last years, developers like to copy-paste. Developers like to copy-paste a lot. We know this popular publishing, copy-pasting from Stack Overflow. People copy-paste from your documentation as well. And when you are creating snippets for your documentation, do a bit of effort. Make sure that when developer is copying something, it's going to compile. You can provide some import statements, a bit longer code snippet, but make sure that then developer is copying something, is going to compile instantly. It's going to simplify his life a lot and provide a better user experience in general. And there is more. If you want to have nice UI for your documentation, you can use tons of different documentation generation tools. You can use just GitHub wikis, we are personally using mkdocs. You can use Jekyll with documentation team. There are tons and tons of tools that allow you to generate beautiful documentations. And I highly recommend you to go through Google Developer Documentation Style Guide. It was published, I believe, 2 months ago. There's a collection of how documentation should look like. They describe not only which parts of documentation should be included, but what grammar should you use, what tone should you use, how to write code snippets, and tons and tons of documentation. I didn't like to learn native language in the school or in the university, but reading this reference documentation style guide is actually amazing. When they describe why you should use active voice in the communicating in the documentation and not passive, why you should use future tense and not present and stuff like that, all those tiny details are described there. So I highly recommend it to check it out. And as I mentioned, like favorite source of copy-pasting the code can be Stack Overflow, can be your documentation, but there is one more thing to copy documentation, to copy the source code. It's your demos. Usually when you ship a library, you always ship a reference application of how to use your library. And a few things that we learned over the time about demos is that first, of course, they should be well documented. We literally provide Java docs to our documentations that this is an example of using this API for this case. This is a sample code to use our API for this scenario. And when you write a demo application, don't try to design a nice architecture just to make sure that the code that touches your library is separated from everything else. So when developer is going to look through your applications, he can clearly find the class where all interactions with your library are performed. Okay. Now let's talk about support. Imagine we passed through development phase, our client integrated. Now what? Now you are getting a support request. Maybe those are support requests during the integration time, or it can be a support request when your library is already in production and used by some library. And basically, you have to prepare yourself to two types of those support requests. Problems during the integration time, and problems already in production. Let's talk how to tackle the problems during the integration time. If I'm integrating a library, and I'm creating a support ticket to the owner of the library, I need to collect as much information as possible. And you as the developer of the library should expose easily at least the version of the SDK. And I have to say, not a lot of libraries are doing that. In our case, we are just providing a runtime method to get the library version, and we always have a README file where you can find the SDK version, but often you start using the library, and the only way to find out which version of library you're using is somewhere deep in the Gradle files or somewhere else. Or if you're including jars, that's nearly impossible. If you're logging something to Logcat from your library, try to provide unique tag so developer can easily filter logs are related only to your library and send it to you. What we found over the course of a couple of years, developers are freaking about privacy of their logs. I have no idea still what the hell are they hiding in those logs, but we had a developer who manually went through thousands of lines of code and removed everything that was not related to our library. After that, we introduced prefix GetSocial to all our log tags. So think about that, how developer can provide you quickly all the logs related to your library. We also provide a debug configuration. Debug configuration is something that enables much more logs, because when we ship library, we enable only warning and errors. And when we're actually trying to help our clients, we need much more information, and we provide an option how to get that. And we provide actionable errors. When you start developing library, you always, and especially when you are in a rush, we tend to test or think about only happy paths. But if you have time, or even if you don't have time, think for a second on how developer is going to recover from errors your library is throwing. Provide a way for developer to distinguish between different types of errors. I'll talk about that on the next slide, but one trick that we found about enabling debug configuration, you know that in Android you can set system properties. And in Android, you can actually set a system property and fetch the system property in the runtime and enable debug logs for your library, even if you just downloaded the application from the App Store. Not possible on iOS or Unity, but on Android, that's amazing features that allows developer just to execute one simple command line in the ADB and he can send us all the bug logs that generated by our library. And about actionable errors, you may provide a descriptive message, but developers are not going to parse your descriptive message. We use error codes to distinguish between different errors. You can use like heuristics of different exceptions, but provide a way to distinguish between your errors, because some errors you may want to be recoverable, some errors they are not recoverable. So developers have to have a way to distinguish between them. If you are solving the user-side problems, usually the way how developer finds about them is through error view in the Google Developer Play console or Crashlytics or something like that. And when you get a Crashlytics report, for instance, you want to have like all the information, like as much information possible to understand like what kind of errors, like what was the root of the problem for the error. In one of the old versions of our SDK, a lot of our errors were like something went wrong and a huge stack trace. What went wrong? Where went wrong? What were the values? You have to guess. So try to provide, when you are throwing an exception, try to include into the message some information that may help you to understand what was the root of the problem when you're going to get this message back through Crashlytics from your client. And if you have a chance, I highly encourage you to build an error analytics. When you're developing an application, you're probably going to use Crashlytics or similar tool. You cannot include Crashlytics to your library, but you can develop it on your own, something smaller, something internal. And tools like that will allow you to build a dashboard and identify problems before your clients are going to notify you about that. Like in our case, we have a huge analytics platform like for our own needs, but what we developed like a year and a half ago is like a tiny version of the Crashlytics. We can track all the information about the device and record all the exceptions. And later, we just dump all this to the Sumo logic. It's just a log parsing platform, and we can build all nice graphs like to understand that you see here, like we had some problematic release, and we can see all the spikes in the errors that are happening, or like all the spikes for our clients that are happening. And what is even better, Sumo logic allows you to query those logs. So you can group them and understand how many clients are impacted by the problem you introduced in the previous version, to understand if you have to run, like, to work to fix it like right now, or you can wait to the next release. Think about support and how you're going to help your clients ahead. That's going to save you a lot of time, and it will build a loyalty for your clients. Because if they see that you are one step ahead of them, that they just contact you, hey, we found this problem, and you say like, ha, I fixed it yesterday. They're going to appreciate that. And quickly about updating the library. We always were asking ourselves why developers update the libraries. And the truth is that developers don't like to update libraries. I personally don't touch upgrade the library until like absolutely necessary. Maybe I need a new feature, or there is some compatibility issue, but other than that, I prefer not to update library at all. And usually what happens when I upgrade a library, you drop new version, you build, and you get compilation errors. And I'm pretty sure that a lot of you face the same situation, and that not the smooth experience. That's something that will get us mad over and over again. And the important thing here to understand is to, if you're going to set expectations right to your clients, of when to expect a breaking changes, when to expect a compilation after upgrade, everything will be fine. You have to ensure smooth updates. First thing is to use deprecation cycle. For instance, if you want to change a return type of the method from list to set, like we did in one of the versions, mark this method as deprecated, introduce new method, and say when when exactly this method will be removed in which version of the documentation. Next thing is semantic versioning. I'm pretty sure you are all aware of that, but just to recall, in bug fixes, we only, API stays exactly the same, there are just bug fixes. In minor versions, we can introduce new features, but when we upgrade from minor to minor version, compilation should pass. And major version is the only version change that allows you to do breaking changes. That's where developers have to fix compatibility issues and compilation time issues. One trick that we looked and thought about implementing was version packages. If you're using OKHTTP, you probably noticed that they used to have something like com2 OKHTTP package. Now they have OKHTTP3 package, and probably they're going to increment just a number here. In case of our library, it didn't make much sense to have this versioning, because you either use our tools or not. But in case of OKHTTP, the communication framework, this versioning of the packages will allow you to use second and third, or whatever versions of library in parallel. And you can do even A/B test which version is performing better. And provide changelogs. Again, it's about setting expectations. You have to list in the changelog what was fixed, what are new features, what were deprecated, and how to upgrade, actually. Just an example of our changelog. To sum up, we, as a library developer, we have to take care not only about our development environment. We have to think about how we are going to impact all those developers who are using our library. In case of GetSocial, our tools are used by more than 30 million users on a monthly basis. That's a huge amount of people. If we are going to introduce issue, that can mean death to our business. That can mean death also to business of our clients if something will go terribly wrong. You have to understand of what impact you are creating. In general, according to Safe SDK, in average, games are integrating 17 SDKs. Can you imagine? 17 SDKs in average are using by each game. If your library is not good enough, if your library is hard to integrate, if your library is crashing, you will be knocked out of those 17 SDKs as fast as possible. You have to build the best solutions possible. Developing is only the first step of the process. You always have to think on how you're going to support your users on the integration process, whenever it will be feedback channels, documentation, some tools that are going to help you to integrate faster. You have to think how you are going to support your clients, how you're going to run smooth updates. Only when you are going to have this, you can achieve the perfect satisfaction from your client. I always try to put myself into the shoes of our clients. We are always building tools, and I encourage you to build tools that you want to use. You as a developer, you don't want to deal with compilation time issues after upgrade. You as a developer, you don't want to go and spend 3 weeks or 3 days to figure out why something is not working. Try to put yourself in your customer's shoes, and then you're going to build much better products and make your developers happy. Merci. I believe we have time for some questions. Nobody says no, so probably yes. Can we have a microphone over here?
Thank you very much for all those tips. I'm not sure I got how you fixed the initialization issue thanks to the content provider. It's just, I wonder, what's the life cycle for those components that you will initialize with the content provider?
Okay. So content provider on create method is invoked before anything else. For instance, when you are receiving the same install broadcast from Google Play, before broadcast will be invoked, your content provider will be invoked all the time. Content provider is something that is going to be created all the time before any other component of your application. And inside content provider, you have access to the context. From the context, you can hook up to all activity lifecycle. You can subscribe to activity on create. You can subscribe to any lifecycle event inside. And if you're interested, I can show you after the session like just our source code and to show how it works. But from content provider, you can get access to all the events, like all UI events and all application lifecycle events.
OK, thank you.
There is one more question on the left, like over there.
You were talking about continuous integration, static analysis, and integration tests, but I don't recall you talking about unit tests. Do you have them, and how important are they in your development lifecycle?
So the question was if we have unit tests. Yes, we do. We have tons and tons of unit tests. But the reason why I didn't cover them in the presentation, they don't really affect public API, and that was the focus of the topic. But yes, we have hell a lot of unit tests. We tried to do test-driven development, and we did it for quite some time when we just started developing the application. But now we don't do it that much, but we have tests for all critical parts. Any other questions? One more here. So the question was about beta testing. How do we do beta testing? OK. We have just a usual QA lifecycle. Like when we prepare a new version, like we have what we call release trains. So basically, every 2 weeks we have a release, and we don't really have like all those 10 features have to get into this train. We'll put into this release all features that were ready by the moment when this train, release train should depart. So 4 days before the release, we do a feature freeze. We create release branches. We update all the metadata for the release. And then our QA team is doing regression testing. We run like all our automated test suites on our test farms, like not on our test farms, but on Amazon test farms. But that's how we do beta testing. We don't do public beta testing. Probably we should. Like we do some tests with our clients for not released versions, but it's more an exception rather than a rule.